We're in chapter 1 and we're going to do section 4 first. We're skipping section 3 because section 3 is made for 8th grade type math classes. So if you're ever teaching one, you can use section 3. In section 4, we're solving differential equations by separation of variables. So we'll start with problem number 2.
Your thing's done.
So, any other minor problems you want to point out?
Yeah, here.
All right, there we go. So that means we're gonna, if we have x's and y's, we're gonna put all the x's on one side of the equation, all the y's on the other side of the equation, and integrate both sides. So that's the plan. So we have something that looks like that, and we say, okay, well, looks like if I rewrite that dy dx is minus 2x y squared, and then I could write dy divided by y squared is 1 minus 2x dx. So I could do that. Now I have all the y's on one side of the equation, all my x's on the other side of the equation. This is pretty simple. I normally put the c only on one side of the equation. It'd be redundant to put it on both sides, the constant of integration. And what's this? This is going to be minus 1 over y, right? So then I'd say 1 over y is x squared minus c. But I wouldn't put a minus c, I just put a plus c because the c would take up the minus sign. And then I'd say y is 1 over x squared plus c. Then I'd be, then I'd sort of like to check my work, right? Anyway, so we'll check our work. So if I have y checking. So if I have y is equal to x squared plus 2 to the minus 1, then y prime would be minus x squared plus c to the minus 2, right? And the original equation said that y prime plus 2xy squared is supposed to be 0. Okay, so I've got minus 1 over x squared plus c squared plus 2x times y x squared plus c to the minus 1 squared is supposed to be 0. It doesn't appear that it's the case, and why not? Because when I took the derivative, I didn't put a 2x there. So if I would have put a 2x in the derivative, then I would have had a 2x here, and then I would have seen that they do cancel out, and check. My work checks. And I do apologize that we can't see enough of that screen at the same time, but that's what I would do. I would check my work after it was done. Okay, good enough? All right. We're supposed to do all of them, so I guess I'll do number 4 next. That was 2? So number 4, 1 plus x dy dx for y. Alright, so I'd probably go with dy over 4 over y is equal to 4 1 plus x dx. Integrate both sides. Looks like natural log y is equal to 4 natural log x plus 1. And then I'd rewrite that as natural log y plus c. Would be natural log x plus 1 raised to the 4th power plus c. And then I'd raise them both as powers of e and say y is equal to c x plus 1 to the 4th. Is that what I would do? Yeah, I think that's probably what I would do. And I wonder if that's going to check. Well, y prime, so I'm going to checking, is equal to 4c x plus 1 cubed. And 1 plus x times 4c x plus 1 cubed is supposed to equal to 4y. And what is y? Y is c x plus 1 to the 4th. And for some strange unknown reason, I got 2 in a row right. So that's pretty disgusting, I know. I apologize for that. I'll do better on the next one. I'll try to mess it up. Number 6. No, I won't do that. But yeah, I might do that. Who knows? 3 square root of xy. Okay, so I'm going to have dy divided by the square root of y is equal to 3 square root of x dx. So, and I have no idea why that's happening. I'm going to integrate both sides. And I'm probably going to go and change this a little. So I've got the integral of y to the minus 1/2 dy is equal to integral of 3 x to the 1/2 dx. That's better to do than trying to do the square root guy. Okay, so this is going to be y to the 1/2 divided by 1/2. And this is going to be 3x to the 3 halves divided by 3 halves plus c. Okay, so I've got 2 square root of y is equal to 2 x to the 3 halves plus c. I'd go and divide by 2 square root of y x to the 3 halves plus c. I wouldn't put c over 2 because the c would just grab that 2 and put it underneath. And then I'd square both sides. Y is equal to x cubed over x 2/3. 2/3 plus c squared, and I'd probably just leave it like that. Number 8. Anybody know how far we're going? I only have to go up to 38. I don't think I'm going to get there going this fast, am I? Dy dx 2x secant y. Well, it's about time we get some trig. So I've got do 2y secant y 2x dx, integrate both sides. I got x squared plus c on this side. Now, secant is 1 over cosine, right? So that's the integral of cosine y dy. The integral of cosine would be sine. So that would be sine y. So we say y is the arc sine of x squared plus c. And we'd probably do something cool, like look in the back of the book and see if I got the right answer. There's no real reason to. I know I do, right? 1, 4, is this number 8? The arc sine of x squared plus c. All right. So we'll just leave my peanuts in that spot in case I want to go back. All right, well, that was okay. Number 8. Number 10. 1 plus x squared dy dx. 1 plus y squared. It'd be nice if I put the x squared and the y squared in the right spot, wouldn't it? All right, how about dy 1 plus y squared is 1 over x, 1 plus x squared dx. Integrate both sides. Okay, so it looks like I've got minus 1 over 1 plus y is equal to minus 1 over 1 plus x plus c. Is that what I have? Yeah, I think so. All right, so I'd probably get rid of the minus sign. 1 over 1 plus y is equal to 1 over 1 plus x plus c. And then I'd ask myself, so do I really want to solve that for y? So we have implicit answers and explicit answer. An implicit answer, an explicit answer would be y is equal to something. An implicit answer would have y in it someplace, but I'm not solving for it. See if the author solved for, it's number 10. And he's doing this, oh, he solved for y of x. All right, so if he solved for y of x, we have to solve for y of x. Okay. Typical. All right, so this is going to be y 1 plus 1 over 1 is equal to 1 plus c plus x over 1 plus x. Then 1 plus y will be 1 plus x over 1 plus c plus x. So y would be 1 plus x. Oh, that can't be. Get it? 1. This has to be cx. All right, that's better. 1 cx. Cx. 1. We'll call it c plus cx minus 1. There, is that better? Can I do that? Number 10. 1. Oh, they keep it out. All right. They keep it out. We'll keep it out. Okay. And so that'd be our final answer. And it's checked by back of book. Looking at number 12. These aren't going to get complicated until I have to do substitutions and other such nonsense, which will happen pretty soon. So I got y dy dx is equal to x y squared plus 1. Now this looks like a inverse trig function. No, it's not. Y over y squared plus 1 dy is x dx. Okay, I'll do the right-hand side. You guys do the left-hand side. X squared plus c. What do you think? 1/2 natural log y squared plus 1. Is that what you think it is? Is that what you were thinking? Yeah, that's what I was thinking. We'll multiply both sides by 2. I don't think so. Natural log y squared plus 1 to the 1/2 x squared plus c. We're going to raise them as exponents of e. Y squared plus 1 to the 1/2 c e to the x squared. And now we're going to square both sides. Y squared plus 1 c e to the 2x squared. And then we'll say y is equal to c e to the 2x squared minus 1 square root. And we probably put a plus or minus sign. So that was 12. And wouldn't you know, if they left it y squared plus 1. So if I go back to here, they left it y squared plus 1 is equal to this guy. So the author left it in an implicit form and didn't bother to do anything else with it. Oh well. Some grad student does these problems anyway. Number 14. Dy dx. 1 plus the square root of x, 1 plus the square root of y. Well, that looks particularly simple. Does that look simple enough? 1 plus the square root of y dy. 1 plus the square root of x dx. Integrate both sides of the equation. Y plus 2/3 y to the 3/2 equals x plus 2/3 x to the 3/2 plus c. 14. And that's the way the author leaves it. He multiplies through by 3, so and calls it 3y plus 2y to the 3/2 is equal to 3x plus 2x to the 3/2 plus c. So he goes and multiplies through by 3 to get rid of the fraction, but I don't see any technical reason why we'd need to do that. I don't see any difference between those two guys. Not even in S. Okay, anyway, back to number 16. Number 16. X squared plus 1 tangent y dy dx equals x. So I got tangent y dy x over x squared plus 1 dx. Integrate both sides. Well, we just did the one on the right, right? So we know that that's 1/2 natural log x squared plus 1 plus some constant c. Now, the integral of tangent Is that secant, cosecant, or something like that? Luckily, we have a table in the back of our book that tells us those things. So the integral of tangent gives us tangent to the end, but it doesn't give us just tangent. Is that in the front of the book? The integral of just tangent? Yes. Okay, there we go. Integral of just tangent, natural log of the absolute value of the secant. Yes, I remember that one. Do you remember that one? Yeah, that's a simple one. Yeah. Natural log, absolute value of the secant of y. Well, isn't that wonderful? So we put the 1/2, so natural log secant y is equal to natural log to the 1/2 power plus c. We raise everything as powers of e, so we have secant, absolute value of the secant of y is equal to c x squared plus 1 to the 1/2. And is that the way our author leaves it? And the answer is no, he does a inverse secant thingy. And I'm not sure I'm too happy with that, because that means he dropped the absolute value and called y as the arcsecant of c square root of x squared plus 1. I'm not so sure that those two are the same answer. That you can just go and drop the absolute value like that. But that's what he did, so it must be okay. Not, I don't know. I'd have to think about it more. Now, number 18. X squared y prime 1 minus x squared plus y squared minus x squared y squared. Now, 17 has a hint, which says the factor, which 18 doesn't have the same hint. But clearly we're going to have to factor this, otherwise we're not going to get the right answer, right? We're going to sit here for a long time thinking about it. So if I have 1 minus x squared times 1 plus y squared, am I going to get that? Boom, 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 boom. Yes. So now I got it factored. Now with it factored, I can solve it. So I got y prime 1 plus y squared, well, dy 1 plus y squared is equal to 1 plus x squared divided by x squared dx. All right, well, dy 1 plus y squared equals, x to the minus 2 plus 1 dx. Integrate both sides. On this side I should have minus 1 over x plus c. Is this arctangent? Is that what that is? I'm thinking that that's arctangent. The integral of 1 plus y squared. Yeah, that's arctangent of y. Arctangent of y. Don't forget to use the front and back cover of your books looking for integration tables. You're probably not going to have all those guys memorized. So if it's the arctangent of y, then y would be the tangent of x minus 1 over x plus c. All right, so now we're doing, starting with problem number 20, we're doing the same thing, but we have an initial condition so we can solve for the constant of integration now. So that ought to be much more fun. Number 20. dy dx 3x squared y squared plus 1. And y at 0 is 1. Okay, called dy y squared plus 1 is equal to 3x squared dx. I integrate both sides. I remember that this is the arctangent guy again. Is equal to x cubed plus c. I apply the initial condition, which is y at 0 is 1, y at 0 is 1. What's the arctangent of 0? The arctangent of 0 is 0, right? So if the arctangent of 0, the tangent of 0 is 0, so the arctangent of 0 has to be 0 too. So I got 0 is equal to 0 plus c. So it looks like c has to be 0. No. All right. It's too late in the day. Not thinking about this right at all. All right, so y is equal to the tangent of x cubed plus c. Okay, that's better. Y at 0 is 1, which means the tangent of c has to be 1. So c has to be pi over 2. Pi over 4? Pi over 4, which is 45 degrees. Okay, so final answer. Y of x is equal to the tangent of x cubed plus pi over 4. And that was problem number 20, so turn to the back of the book, and yep, that's what it is. All right. 21 we'll skip. 24. 24 looks funny. We'll do it next. Number 24. Okay. So I've got dy over y is equal to dx over tangent x. Integrate both sides. Okay, so I've got natural log of y is equal to, what is the integral of cotangent? Okay, I don't remember the integral of cotangent, but it's clearly the natural log of the sine. Natural log sine x plus c. Raise them as powers of e, and I have y of x equals absolute value of the sine x plus c. And I know my initial condition y at 1/2 pi is equal to 1/2 pi. Okay, so the sine of 1/2 pi, of pi over 2 is 1, right? Yeah, the sine of pi over 2 is 1, and so I want this to be 1 plus c. So c is going to be pi over 2 minus 1. And so my final answer would be in the form y of x equals to the absolute value of sine x plus pi over 2 minus 1. Really? No, it's not. And where did I mess it up? I messed it up right there. It's not plus C, it's times C. And I did that right all the other times. I don't know why I did it wrong there. But the fact of the matter is I did. So this is going to be 1/2 y is going to be equal to C times 1. So C is going to be pi over 2. And my final answer is going to be pi over 2 times the absolute value of sine x. And now we agree with the author, who again dropped the absolute value for some unknown reason. Okay, I'm going to drop down to 28. Number 28. Okay, so I've got dy divided by cosine squared y is equal to dx over 2 the square root of x. And I have that y at 4 is pi over 4. Okay, going to integrate both sides of the equation. Well, I think I got the right-hand side. Square root of x plus c. What is the integral of secant squared? Anybody remember? Anybody? Didn't you guys learn all these integrals? I mean, really? The integral of secant squared. Oh, bummer.
Is that tangent plus C?
Hmm?
Is that tangent plus C?
What?
Tangent.
You just
It goes number 8 on top.
oh, there's a secant squared one on the front page, and I'm looking at the wrong place. Is that what you're trying to tell me?
Yeah.
Oh.
It's number 8 on top.
Oh, there it is. See, there it is. Yeah. So that's just tangent y. Tangent y. All right. So y is equal to the arctangent of the square root of x plus c. Okay. Y at 4 is going to be pi over 4. Pi over 4, which has to be the arctangent of 2 plus c, right? Now, the tangent of pi over 4 is 1, right? So that means c2 plus c is equal to 1, implying very strongly that c is equal to minus 1.
Where did you get the 2 from?
When I put the 4 in there and I took the square root of it, I took out my calculator like this and I put square root of 4 and I hit the button and it said 2. That's where I got it from. Yeah, it's magic, I know. Yeah. And so final answer, y of x equals arctangent, square root of x minus 1. Oh, very nice. Very nicely done. All right. Well, let's see. We'll do 34, and then we'll go on to the next section. 34. A certain culture of bacteria. The number of bacteria increased sixfold in 10 hours. How long will it take for the population to double? Okay, question mark. No, 2x, question mark. Okay, so that's all we got. Is that enough? Oh, I hope so. All right, so the change in the population, change in time, change in population, change in time, is going to be equal to some constant times the population. Okay, so change in population divided by the population is going to be k dt. I integrate both sides. The natural log of the population is going to be kt plus some constant. Population at times t is going to be c e to the kt. And population at time 0 is going to be c. Okay, so population at times p is going to be population 0 e to the kt. All right, now we know that in 10 hours we're going to be 6 times. Okay, so at 6p0 we're going to have p0 e to the k times 10. Okay, so 6 is e to the 10k. I'm going to take the natural log of both sides, and I'm going to come up with k is the natural log of 6 divided by 10. Well, that being the case, I know that the population at times t is going to be the initial population e to the natural logs of 6 over 10 t. And now I want to find the t when I double. Now if I was playing golf, I'd want to find a t in my caddy bag or something like that. So 2p0 is equal to p0 e to the natural log of 6 over 10 t. 2 is equal to e natural log 6 over 10 t. I take the natural log of both sides, and I get natural log of 2 is natural log 6 over 10 t. And now it's almost time to take out my calculator. T is going to be 10 natural log 2 divided by natural log 6. And that is going to be the time that we go. And it better be a number less than 10, right? And if it's not, then we'll have to do something else. So 10 times natural log. This is my first semester on this calculator. I have no clue where the natural log button is. All right, there it is. Natural log 2 divided by natural log 6. And I end up with 3.8685 hours. And I say, well, there's no way I have that many significant digits. We'll go 3.9 hours, and that ought to be good enough. Okay? And I do a radiation problem the same way. If I had a radioactive isotope, I would say the change in the amount, change in time is equal to k times the amount I have, and solve it the same way. Okay, moving on to 1-5. Okay, on page 47, there's a proof showing the following when I get to the end. And what it shows is that if I have something that's in the form y prime plus pxy is equal to qx, if I can get my differential equation into that form, then I can solve for y directly, where px and qx are functions of x only. Okay, that's why they say px, qx. So there's no functions of y. If I can get it in that form, then I can say y is equal to 1 over e to the integral px dx integral qx e to the integral px dx. Now, that particular form is bad from a mathematical point of view. We would never write it like that as a mathematical person. So that would be the way you'd write it as a technical person. As a mathematical person, you could write it px dx. But that's the way we're going to use it. Qx e to the integral p tau d tau dx. So you wouldn't have inside your integral another integral with the same variable of your integral. You'd never do it that way. But what you're going to do is you're going to solve for e to the integral px dx separately. We call this our integrating factor, or we call it our fudge factor. Either way, depending on what your major is, you might call it one or the other. So if you're an architectural major, you'd probably call it a fudge factor. And if you're an electrical major, you'd probably call it an integrating factor. And you solve that separately, and then you'd put it in this equation to solve directly for the differential equations. So there's a whole class of problems where I can put it in that form and then solve it. Okay, so that's what I'm going to do. And I think that might be all I'm doing in this section. That would be convenient, wouldn't it? Yeah, it looks like that might be all I'm doing. Let's hope so. Okay. So I'm only going to 27 this time, and then I'm going to the story problems. Okay, so number 2. Y prime minus 2y is 3e to the 2x. And I also know that y at 0 is 0. Okay, well, I see that my px is minus 2, and my q of x is 3e to the 2x. I see that e to the integral px dx is e to the integral minus 2 dx, which is going to be e to the minus 2x. And so I know y is going to be 1 over e to the minus 2x integral qx 3e to the 2x e to the minus 2x dx. So y is going to be e to the 2x integral 3 dx. Y is going to be e to the 2x times 3x plus c. So y is 3x e to the 2x plus c e to the 2x. I'm going to apply my initial condition, which is y at 0 is 0, y at 0 is 0. Okay, that guy's 0, this guy's implying c is equal to 0. Final answer, y of x is equal to, do you remember? 3x e to the 2x. 3x e to the 2x. We'll do a quick look in the front of the book. 3x e to the 2x. Now, why do they give me initial condition if the initial is condition, find the corresponding particular solution? Okay, so it wanted both that guy and that guy. It wanted both of those as my final answer because it wanted the general solution and the particular solution both. Okay. Number 4. Y prime minus 2xy e to the x squared. Okay, so p of x is equal to minus 2x, q of x is equal to e to the x squared. I want my integrating factor e to the integral minus 2x dx, and that's going to be e to the minus 2x squared. And I'm going to have y is equal to 1 over e to the minus 2x squared. Q of x, which is e to the x squared, times e to the minus 2x squared dx. Y is going to be e to the 2x squared. And that looks like e to the minus x squared, doesn't it? So I got the integral e to the minus x squared. What am I doing wrong? If anything. Oh, I know what I'm doing wrong. What's the integral of minus 2x dx? Minus x squared, right? Who put that 2 there? Minus x squared, minus x squared. These guys are just 1, so that's going to be dx. Okay, there we go. Much better. Is that much better? So y is equal to e to the x squared, e to the x squared, x plus c. All right, do we have an initial condition? No, we don't. We're done. So number 4, x e to the x squared plus c e to the x squared. Check with backup book. Okay. Number 6. Oh, you gotta be kidding me. X, y prime plus 5y is equal to 7x squared. Y2 is 5. Oh, well, we're not in the right form. I guess we can't solve it. Going on to number 6. Oh, guess we can't do that, can we? Okay, so we got to put it in the right form. So I'm going to divide everything by x. Y prime plus 5 over xy is equal to 7x. Okay, now I got p of x equals to 5 over x, and q of x equals 7x. And I want the integral of e to the 5 over x dx. Well, boy, that was really bad one. Oh yeah, e to the integral. All right, that's better. 5 goes on the outside, it becomes a natural log. The 5 goes as an exponent as the x. E to the natural log of x to the 5th is just going to be x to the 5th. So it's going to be x to the 5th. All right, so y is going to be equal to 1 over x to the 5th integral. Anybody remember what? Oh, there's 7x. 7x, x to the 5th dx. Y is equal to x to the minus 5 times x to the 7th plus c. Is that right? Yep, sure is. Y is equal to x squared plus c over x to the 5th. Okay, good enough? No, not good enough. There's an initial condition. It would be good enough if we didn't have an initial condition. But we have an initial condition we have to solve for. Okay, so our initial condition is y at 2 is 5. Okay, so y at 2, which is 5, is going to be 4 plus c divided by 32. I sort of vote for c being 32. What do you think? So c is 32. So my final answer, y is equal to x squared plus 32 divided by x to the 5th. And that checks with the back of the book because I just looked. All right, well, those guys are particularly boring. Why don't we move down to something like 16, where at least we have a sine and a cosine to deal with or something, right? Number 16, y prime equals 1 minus y cosine x. Y at pi is 2. Right. Well, again, we're in the wrong form, so I guess we can't do it. Until we change the color of our ink, anyway. All right, so I got y prime plus y cosine x is equal to cosine x. Okay, so p of x is cosine x, and q of x is sine x. I want e to the integral of px dx. E to the integral of cosine x dx. E to the plus sine x. Oh, gee, that doesn't look good. I don't know. Right here. See where it says sine x right there? You want to borrow my glasses? So you guys blind? You know, you're back in the 3rd row. Oh, you mean this sine x here? Oh, bummer. I was waiting for Andrew to correct me. That's what I was doing.
He did.
Oh, he did? Oh, bummer. All right, so cosine x. Is that better? You happy now? Except this one's really sine x. Now I erase the wrong thing. All discombobulated here. Sine x. Okay, so that being the case, y is equal to 1 over e to the sine x integral cosine x e to the sine x dx. Oh, well, that is an easy enough integral to do, so that's not I mean, why don't you know, at least we could have had a harder integral. E to the minus sine x times e to the sine x plus c. Okay, so y is equal to 1 plus c e to the minus sine x. Okay, now we're going to apply the initial condition, which no one remembers what it is, including me. We're probably working on 16. Y at pi is 2. Okay, so y at pi, which is 2, is equal to 1 plus c e to the sign of pi is 0, right? Okay, so clearly c is equal to 1, and my final answer would be y is equal to 1 plus e to the minus sine x. Is that right? Don't know. Well, not until I check it to make sure I'm right. Yeah, oh, I'm right. This is way too easy. How far do you want me to go?
Oh, that's fine.
That's fine enough.
Right, you can go on then.
Let the record note that I'm allowed to continue. Well, we have plenty of time too, right? Wow. Maybe I should tell a joke or something. That was 16? So now we'll go to 18. 18. I think my eyes are crossing up here or something. Xy prime is equal to 2y plus x cubed cosine x. Okay, so I'm going to divide everything by x. Y prime minus 2 over xy is equal to x squared cosine x. Okay, so px minus 2 over x qx x squared cosine x e to the integral minus 2 over x dx. Okay, so the minus 2 is coming to the outside. I'm going to have natural log. The minus 2 is going to make it a minus x squared. The e to the natural log is just going to give me x to the minus 2. Okay, so y of x equals 1 over x to the minus 2 integral q of x.
Is it supposed to be e to the minus x?
Where?
Where the,
Right here? Right
No.
there?
Yeah, it looks to be e raised to the power.
Are you trying to tell me that I left too many steps out and you couldn't follow me? That's the whole purpose. Yay! Okay, so I'm going to go back and add some steps for the second Andrew, because the first Andrew didn't want any because he knew it all. He didn't have to know nothing. All right, so you can tell me to quit anytime you want. Anytime you're embarrassed enough that you had to ask that question, just tell me and I'll quit doing what I'm doing. Let's see, edit, paste. All right, so adding in the maximum number of steps for complete clarity. Okay, so that's e to the minus 2 integral 1 over x dx. That's e to the minus 2 natural log x. That's e to the natural log x to the minus 2, which is equal to 1 over x squared. Oh, I left out a step. I'm sorry. I'm going to put that step back in, which is equal to x to the minus 2, which is equal to 1 over x squared. Okay, is that better? Yes, Virginia, I expect you to be able to do that. Skipping all those steps in your head. No. Yeah, putting the steps in, I expect you to do it. Yeah. But my job is to remove as many steps as I can until you cry uncle. Once you cry uncle, then I got to put them back in. All right, so now I've got x squared cosine x times x to the minus 2 dx So y of x will be x squared times integral, that'd be sine, right? Sine x plus c. Do I have an initial condition? No, I don't, so I am done. Checking the back of the book for 18, and I find that I got the right answer. Okay, check. Back of book. Okay, so it's 18. Do we want to do 20? I guess we do. I haven't found one that's hard yet. Y prime is equal to 1 plus x plus y plus xy. And y at 0 is 0. Well, I don't seem to be in the right form. Y prime equals 1 plus y, 1 plus x. Okay, that's interesting. Okay, all right, so y prime minus 1 plus x y is equal to 1 plus x. Okay, so p to the x is equal to minus 1 plus x, and q to the x is 1 plus x. All right, so we want e to the integral of minus 1 plus x dx. Okay, so the minus sign comes out. E to the minus x plus x squared over 2. No, it's not. How do I know it's not? Given the information you can see on the board, how would I know that? Well, I know that because I can't get any good answer out of that. My integral is really bad that I have to solve, so therefore I made a mistake. So we come back up here and we see that this is really 1 over, and this is really 1 over, right? Yeah. Or is it? Oh boy. No, it's not. I did it right. Did I not? Minus that. No, I did it right. Wow. Okay, well, it is what it is. Okay, it is what it is. Okay. We will have to proceed thinking that that's right. All right, so y of x equals, we don't have to do it in red though, 1 over e to the minus x plus x squared over 2 integral 1 plus x e to the minus x plus x squared over 2 dx. Okay, well I can solve that. That's not a problem. Okay, good. So y of x is e to the x plus x squared over 2 times. If I take the derivative of this guy, I get that guy with a minus sign, right? So this is going to be minus e to the minus x plus x squared over 2 plus c. Okay. So y of x equals minus 1 plus c e to the x plus x squared over 2. Now, do we have an initial condition? Yes, we do. Y at 0 is 0, clearly implying c is equal to 1. Because at 0, this becomes 0, that becomes a 1. So c is equal to 1. So my final answer, y of x is, and we'd have to spell it properly, e to the x plus x squared over 2 plus 1. You wouldn't know, minus 1. Write it down, minus 1. You wouldn't write it minus 1 plus e to the x squared over 2. You put the positive guy first and the minus guy second. All right, so that was number 20. Isn't that lovely? The author has the same answer that we did, but he misspelled it and put the minus 1 first. I tell you, some grad students can't even spell. Okay, well, what are we doing next? 22, 24, 26. We're supposed to. Okay. We don't want to go home early, do we? No. Okay. Guess we'll do 24 next. Do 24, then 26, and then do a couple story problems. 24. X squared plus 4 y prime plus 3x y is equal to x. Y at 0 is 1. Okay, I got to get it in the right form. Y prime plus 3x over x squared plus 4 y is equal to x over x squared plus 4. Okay, so that's p of x. That's p of x. And that guy's q of x. Okay, so we got that figured out. So I want e to the integral 3x over x squared plus 4 dx. So that's going to be a natural log guy, right? E to the natural log of x squared plus 4. And then I got a 3 out there. So I'm going to have to do something about that 3. I want a 2 there. So I'd bring the 3 out. I would divide by 2 and then put a 2 there. So this would be to the 3 halves. Okay. So I've got e to the natural log x squared plus 4 to the 3 halves, which would be x squared plus 4 to the 3 halves. Okay. Excellent. So now I've got y of x equals 1 over x squared plus 4 to the 3 halves. How many people think that that's a 9? Anybody think that's a 9? We can't think it's a 9 because I said 4, right? Integral. Integral what? Integral x over x squared plus 4. X over x squared plus 4 times x squared plus 4 to the 3 halves dx. Alright, so I got y of x equals x squared plus 4 to the minus 3 halves interval. X square root of x squared plus 4 dx. Okay, now when I make this 3 halves, when I do the integral, I'm going to have a 3 halves there. The 3 halves are going to come out here. The 2 is going to come out there. The 2 is going to cancel, but I'm going to need a 1/3, right? Alright, so y of x equals x squared plus 4 to the 3 halves minus 3 halves times 1/3 x squared plus 4 to the 3 halves plus c. And of course, the 3 halves is all, the 1/3 is also multiplied by the c, but the c just sucks it in, and it's not a real problem. So when I get done, final answer, y of x equals 1/3 plus c. Well, it's not the final answer yet because we still have to do the initial condition, y squared plus 4 to the 3 halves. Okay, so that's my almost final answer. But I have an initial condition. Y at 0 is 1. Is that what it is? Yeah, y at 0 is 1. Y at 0 is 1. Okay, so y at 0 is 1/3 is 1, which is 1/3 plus c over. Now, the square root 2 is 2, so this is a cubed. Okay, so c over 8 is equal to 2/3. C is equal to 16/3. So now we're ready to write down a final answer. Y of x equals 1/3 plus 16/3 x squared plus 4 to the minus 3 halves. Right. Could very well be 24. 1/3 16 over 3 x squared plus 4 to the minus 3. Oh, bummer. Can't wait until we get to a better chapter. Where I can't solve the problems. 26. It'll happen soon enough. 26. Okay, so in this problem, I'm going to pretend that y is the independent variable rather than x. Okay, so that's what I'm going to do. So I've got 1 minus, and I'm going to do it with a straight face. dy dx is equal to y cubed. Okay. So how the heck am I going to do this? Okay. So I'm going to say dy dx is equal to y cubed divided by 1 minus 4xy squared. Okay. Then I'm going to say dx dy, and I'm not even going to do that. I'm just call it y prime, x prime. I'm going to say x prime is equal to 1 minus 4xy squared divided by y cubed. And then I'm going to say x prime plus 4 over y x is equal to 1 over y cubed. Okay, so now I have a formula with a p of x and a y of x and y only, because y is my independent variable, and I have an x prime and I have an x. And I'm going to hope that I did it right. Okay, so I did it right. And I find that my p of x is sitting right there, and my y of x is sitting right there. And I want e, or my p of y and x of y. So an integral 4 over y dy. The 4 goes out. This becomes a natural log, which becomes natural log of y to the 4th. E to the natural log of y to the 4th is just y to the 4th. Okay. So x is equal to 1 over y to the 4th integral 1 over y cubed, y to the 4th dy. X is equal to 1 over y to the 4th. This is y dy, which is y squared over 2 plus c. Okay, so I'm going to have x is equal to 1 over 2y squared plus c over y to the 4th. Oh, yes. Yes, what was that, 26? 26. 1 over 2y squared plus c over y to the 4th. How come the author is still getting my answers? That is really bad. Okay. Then we're going to go to problem number 30. What?
Can you scroll up for a second?
Okay, I'll try. 1001.
Right there.
Hey, was that good? Oh, want to go there?
Up a little more. Right there.
Right.
What is that after the integral? That's 1 over y. What?
Yeah. See, because q of y is 1 over y cubed,
Okay.
right? So right there is my q of y. So that's what's sitting there, and that of course makes it the integral of y dy, which is y squared over 2, making it something that we can do, which is pathetically easy. Okay. Now this is probably where I go and spend the rest of the class time just trying to do one problem, trying to figure it out, right? 32. Find constants x and y such that y sub p is a sine x plus b cosine x if this is the solution of, okay, so this is the solution of y prime plus y is equal to 2 sine x. Use the results in part A in the method of problem 31 to find the general solution of the differential equation, blah, blah, blah. Solve the initial value problem, blah, blah, blah. Well, I don't know that we want to do that, but we will solve for A and B, because that sounds like fun. Okay, so I've got that y, not that guy, y sub p, a sine x plus b cosine x y prime of p is going to be a cosine x minus b sine x. Okay? And one of those guys plus one of those guys has to be 2 sine x. Alright, so that being the case, a minus b sine x plus a plus b cosine x is what I have on the right hand side of the equation. Now, sine x and cosine x are linearly independent, correct? Are they not? Yes, they are. That being the case, a minus b has to equal 1, and a plus b has to equal 0. And if I add those two together, I have that 2a has to be 1. And if 2a is 1, that strongly implies a is 1/2. And if a is 1/2, then b had best be minus 1/2. So y sub p becomes 1/2 sine x minus 1/2 cosine x. Okay. So I found a and b. So I did the a part of the problem. Now the b part of the problem, use the results of problem. Yeah, we're not going to do that. Okay. Yeah, I think we just quit there. All right. 35. Rework example 4. That doesn't sound very good. 36. A tank contains. Okay. 30. I never get these guys right. These guys. Well, it is still chapter 1 though, right? A tank contains 60 gallons. 60 gallons. Brine containing 1 pound of salt per gallon. 1 pound per gallon of salt enters the tank at 2 gallons per minute and is perfectly mixed, leaving solution. Leaves the tank at 3 gallons per minute. Okay, so we're going to leave the tank at 3 gallons per minute. Thus, the tank is empty in exactly 1 hour. I agree. Guess we can go on. Oh, A. Find the amount of salt in the tank after 1 minute. B. What is the maximum amount of salt ever in the tank? Okay. Okay, so I got as I was saying, oh, there we go, mixture problems, page 52. Isn't that lovely? Okay, so the change in the amount, all right. So the change in the amount of salt is equal to the rate so the rate, 2 gallons per minute, times the concentration, 1 pound per gallon, minus what? Minus the rate out, 3 gallons per minute, times x of t, v of t, the concentration at times t. Okay, so the change in the concentration is equal to the rate going in minus the rate going out times the concentrations. Okay, so I've got an equation that says x prime plus 3x over 60 minus t, because that's going to be the volume, is equal to 2. Is that the way you see it? X prime, the change in the amount of salt, is equal to 3 divided by 60 minus t, x, the amount that I have, which is equal to 2. Okay, so that looks like the equation I'm supposed to be solving. So, p of x is 3 over 60 minus t. Q of x is 2. E to the integral, 3, 60 minus t dt is E. Okay, so that's going to be a natural log thingy, right? So it's going to be natural log of 60 minus t. And when I do that, I'm going to have a minus t on the outside, and I already have a 3 on the outside. So it looks like I'm going to need a minus 3 there. That's what it looks like. And so that's going to be equal to 60 minus t to the minus third. Okay, so x of t equals 1 over 60 minus t to the minus 3 integral 2 over 60 minus t to the minus 3 dt. Oh, I did that wrong. I did that so wrong. Okay. Two 60 minus t to the minus 3. Okay, do we like the way that's set up? Do we have much of a choice? Probably not. So x of t is equal to 60 minus t cubed. See, what's that integral going to be? Gonna add 1 to it, right? So if I had minus 2, no, if I had minus 60 minus t to the minus 2, and I took the derivative of the minus 2 would go out there, but then I have another minus 1 going out there, so this would have to be positive to have that be positive. Okay, so this is going to be 60 minus t to the minus 2 plus c. Okay, so x of t is equal to 60 minus t plus c 60 minus t cubed. Now, what is the concentration of salt at time equal to 0? It is 0, right? So that's going to be 60 plus c times 60 cubed. Okay, so c is going to be minus 1 over 60 squared. Okay, so x of t is equal to 60 minus t plus minus 60 minus t squared over 3600 cubed over 3600. Okay, I think that might be right. So, what were we trying to solve for? Consider a tank. Find the amount of salt in the tank after t minutes. I've done that. What is the maximum of the salt? Okay, so we have to take, okay, first of all, problem 36, right? So we're going to go back to problem 36. And the answer is 60 minus t minus 60 minus t cubed, exactly what we have. So we solved the problem. I solved the problem right, guys. I don't want to brag or anything, but probably the first time in 5 years I got that one right. So, because normally you get confused by the facts as you're working it. Now, what's the maximum amount of salt? Well, we're going to take the first derivative and we're going to set it equal to 0. And when that, whatever time that is going to be the time I have the maximum salt in the tank. All right, so it's going to be minus 1 minus 3 6 t minus t squared minus 1 over 360. Minus 1. Okay, so 0 is equal to minus 1 plus, because this is times minus 1, so minus 1 plus 60 minus t squared divided by 1200. Okay, the minus 1 goes on the other side of the equation, the 1200 goes on the other side. 1200 equals 60 minus t squared. 1200 equals 3600 minus 120 t plus t squared. T squared minus 120t minus 2400 equals 0. Okay, so using the half quadratic formula, t is equal to 60 plus or minus the square root of 60 squared minus 240, 2000, minus divided by 1. Okay,
Shouldn't that be?
so that is 60, no, yeah, positive. Yep, I agree. So this is 36, that's 24, so that's plus or minus the square root of 1200. Okay, 1200. Where's my on button? Square root of 1200. Boom. Okay, so both of these, how come I have two positive numbers? Okay, so I've got, well, I can't have a number bigger than 60 because at 60 the tank's empty, right? So the right answer would be 60 minus 34.64. $25.359 hours. Is it in hours? Minutes. So that'd be minutes. And then I'd say, well, I probably only have two significant digits. So 25 minutes, I'm going to be at maximum. And no, it's not. Wait a minute. It wants to know how many pounds of salt. Okay, so 20. I still have to find the number of pounds of salt. Okay, so I got to go and take x at 25.359 is equal to 60 minus 25. We'll just make it 25, right? 25 minus 60 minus 25 cubed over 3,600. Yeah, okay. So that's the math we're doing. And then if we don't get the right answer, we'll go back and use more significant digits. All right, so I've got 60 minus 25, which is 35. So I've got 35 minus 35 cubed, 35 cubed divided by 3,600. 23.09, which is exactly what the back of the book says. Pounds. So they rounded it off to 25 and then kept 4 significant digits. What a bunch of losers. Can you imagine? You can't do that. You can't round it off to 2 significant digits and then keep 4. Can you imagine that? Okay, gentlemen. With that, we are done with section 5. Isn't that great? Isn't that wonderful? Which means we can leave on time because we didn't take a break. And that's good too. So we'll do a Control-Alt